Hi, this is SIG Auth for November 1st. On schedule today is a demo for Spiffy Spire. We're going to start with that. There are some polls to talk about and some designs. And then there are a few discussions to end with, but I want to have plenty of time to talk about the KMS stuff that has open polls. So Evan is here to give us a demo about Spiffy Spire, and I'll go ahead and hand it off to you, Evan.
Thank you, David. Yeah, so my name is Evan Gilman. I've kind of been lurking around for a while. I gave a small kind of talk about what Spiffy Spire is, like 2 or 3 SIG Auths ago. So since then, we've been hard at work trying to get the Spire software project off the ground. We've made some considerable progress since then. So here today, kind of just to show you where we are and show you we've got what we call Kubernetes workload attestation working. So I wanted to share that with you as well. And I apologize for my video is my camera is not happy with me today. So this is, first of all, this is a GitHub repo called Spiffy example. And we're in like the Beatrice subdirectory, but if you want to pull this down and play with it, it's very well automated. Just a couple of make commands and you can get the whole Spire environment up and running. So this is kind of what we'll be working out of this repo today. So here is a diagram of what kind of is happening under the covers in the demo. So like I said, it's kind of all tied up by make, but under the covers it's using Vagrant, and we have 3 different Vagrant VMs here. So on the left, on the top right, you see a Kubernetes master VM. So this is running like a Kubernetes API server. We'll also use it to run the Spire server. The bottom right, there's database VM. This is kind of emulating just a bare metal machine or a regular VM, which is running MariaDB. And on the left is we have a single kubelet. And this is not many qubits, like full blown, as you can tell from API server. So on the left we have kubelet node, and kubelet node has scheduled onto it a pod which runs like a blog/forum application of sorts. And then there's 2 MTLS proxies, one on either side, which we feed Spiffy certs into, and then do MTLS between this Kubernetes workload and this kind of bare metal database workload. So that's what I'm going to show you today. There's this one little piece here called this workload sidecar, which could be better named, quite frankly. But basically, it's just a small bit of code which hits the workload API, which is exposed by the Spire agent, pulls the certs out, and then dumps them on disk for Ghost Tunnel. We haven't quite taught Ghost Tunnel how to speak to that API yet, and it's kind of one of the things on our list of things to do. Yeah, so I'll show you how it works. So let me just turn this thing up real quick. Can you guys see my terminal okay?
Yes, we can.
Okay, awesome. Okay, so what we have here is 6 windows. Horizontally is the same host, so there's 3 different hosts, and we just have 2 terminals open on each one. So the top host you can see is labeled Kms Master. That's the one running API server, and we'll run Spire server there. The middle row is 2 terminals on the node which is running kubelet, and the bottom 2 terminals are on the kind of bare metal equivalent database host. So the first thing we need to do is to get things up and running is just start the Spire server. So let's go ahead and do that. Okay, so the Spire server is up and running now. It's generated a CA to do all the signing and everything like that. And now the next thing we want to do is we need to start the agent on the database host. And normally we have like automated node attestation. So depending on the environment, if you're in AWS, GCP, Azure, whatever it is, we can detect that, and we can do native attestation using a Business Identity document or whatever method you deem as acceptable. We don't have anything like that under Vagrant. So instead of automatic attestation, today we'll be using what we call joint tokens, which is similar to kind of the way that Docker Swarm works. So we'll generate a token. And what we're going to do is we're going to assign a Spiffy ID to this token. And this token will be like identify this node. So we'll just call it DB node. DB host rather. Doesn't really matter. So we'll copy this token. These tokens are one-time use only, and there's a TTL associated with them as well, but there's a default in there, so I just didn't specify it. So here we'll start the agent, and I'm going to kick it into debug mode just so that we can kind of see a little better what's going on. Okay, so that server is now, that agent is now running, and you can see the server received an attestation with that token. And you can also see down here that the agent has picked up its example.org DB host Spiffy ID. So now the agent's running, it exposes that the workload API, which is what the workloads use to catch their certificates. And we have this little script over here, this is the same host, of course, which kind of just, it starts that helper code, which interacts with the workload API, and it also starts Ghost Tunnel. So just to kind of show you what happens here, if we start it now, it panics and says fetch 0 bundles. And that's because we haven't declared this workload. We haven't registered this workload with Spire yet. So let's go ahead and register this workload with a Spiffy ID. And when we register it, we need some way to describe this particular workload. So in this case, I'm going to be running the process just as my user here. So you can see that we're UID 1000. So I'll use that as what we call selector. So going back up to Spire server, we'll register it. And we're going to say that the parent ID is the DB host, right? Because that's where we're going to run it. And then we describe the workload using a selector. In this case, it's a Unix UID. And then we're going to give it a Spiffy ID. We're going to call it database. So there you can see that registration, and we call registration entry, has been created. And you can see over here that the agent has picked up this new Spiffy ID available to it. So now if we try to start this again, we can see that it's actually picked up a certificate and Ghost Tunnel has started. And if we look at the Ghost Tunnel process, oops, we can further see that we specified a switch here to say that this Ghost Tunnel process will only allow the clients presenting a certificate with Spiffy ID log, right? So we'll do name verification on both sides of the connection. So now we kind of need to do the same thing on this Kubernetes host. So the first thing that we need to do there is to get the agent running. So we'll generate another token, but this time we'll call it Kubernetes host. We'll do the same log level here. Okay, so that's running. So now you see a little bit of a difference here. The logs are rolling over continuously on this particular agent, and the reason for this is that I showed the diagram previously where inside the pod we're running the blog application plus a Ghost Tunnel plus this helper. But we saw earlier the helper code just exits if it can't get a cert from the API. So for the purposes of this demo, what we did was we just kind of threw that helper into a while true loop. So you see it here just kind of continually trying and exiting, and we just kind of churn through until something is available. So we want to issue a Spiffy certificate to the workload inside Kubernetes. Now, previously, we described it in terms of like Unix primitives, but on Kubernetes, we want to describe workloads in terms of Kubernetes primitives. So here we'll register this blog workload, but instead of using Unix ID, we'll use things that Kubernetes understands. So we'll register with parent ID of the host we gave. And one thing I'll point out here is that multiple hosts within a cluster can share a Spiffy ID. So when you make this parent ID registration, it doesn't necessarily have to be pinned to a particular host. It could be pinned to a cluster or even a subset of hosts, depending on how you set things up. So here for the selector, we want to use a Kubernetes primitive, as I mentioned. We'll use namespace. but obviously namespace is not very granular. So we'll stack the selector with an additional service account selector. So this is going to say that the workload must satisfy both the namespace and the service account constraint and be running on a Kubernetes host with SPIFFE ID K8s host. And when those things are true, we'll issue this SPIFFE ID to blog. Okay, so that entry is then created, and you can see now that there are 2 selectors rather than 1. And right now we only support namespace and service account, but we can actually pull out anything in the pod spec. So a number of options, number of things you can use as selectors will grow quite significantly in the near future. Just a few lines changed to enable support there. And you'll notice that this log has stopped rolling over. And you may also be able to see here that we picked up that blog SPIFFE ID. So now if we look on this host for Ghost Tunnel, we can see that it is in fact running and that we are verifying that the server SPIFFE ID is example.org/database. So now both these MTLS proxies are running. We've fed them certificates from the Spire daemon, and we can actually, hopefully, access this blog thing. Let's see. And there it is. So it's working, and if we go back to terminal here, we can kind of see where Ghost Tunnel has opened those pipes. And so now this is blog running as Kubernetes workload, attested with Kubernetes primitives, doing MTLS with a SPIFFE ID to MariaDB, which is described as Unix primitives on just a bare metal VM, if you will. And just kind of to demonstrate that this is actually traversing this MTLS tunnel, we can kill this process, this Ghost Tunnel process. You can see on the bottom now where those pipes have closed up on the server side. And if we refresh over here, we get a 500. So that's pretty much it. That's the demo. Future demo, what we're going to do is we're going to show the same thing, except we'll show like 5-second cert rotation, and we'll delete the registration entry, which will make that revocation automatic. But that's pretty much it. Workload attestation on Kubernetes using Spire Server. So thank you, guys. I'm curious to see if anyone has any questions. I'm happy to hang around and answer them.
I got 2 questions. One, when you brought up the database host and had it start the Spire agent, how did it know where to find the Spire server?
So that we have the IP addresses all hard coded in this demo. That's why I can hit this blog IP address reliably. So we haven't done like discovery here.
Okay.
It's just assuming that kind of like Spire itself doesn't really solve for discovery. We assume that you have discovery solved in some other way.
Right.
So the agent is configured similarly. Like the agent configuration has to have a name or an IP address to reach the server. So the same story there.
Okay. Second question: how is the Kubernetes workload getting its selector attestations?
So to restate that, you were wondering how the agent is able to discover the Kubernetes selectors from the workload?
Yeah, so like when your little sidecar was connecting to the agent that you were running on Kubernetes node, it knew that it was a particular namespace and a particular service.
Correct.
How's it doing that?
So the way that we do that is we use a special socket option. The API is exposed as a Unix domain socket. There's a socket option there which allows us to get the process ID of the caller. So we do this first. Then once we have the process ID, we check out cgroup on that process. And the way that Kubernetes and Docker currently interact is such that the pod UID is embedded into the cgroup names. So we grab the pod UID from the cgroup names, and then we hit kubelet has a node local API, which may be undocumented. And we hit this thing, and we look for the pod UID in the list of running pods. And then from there, we validate number 1, that it is in fact a authorized and running kubepod that the kubelet started. And 2, get the pod spec from there and are able to kind of build up all those options, properties we call them. Does that answer your question?
Yes, it does. Thank you.
Awesome.
I had a question on the join tokens. You mentioned the join tokens are a bit like the Docker Swarm join tokens. They're bidirectional. I think the Docker Swarm ones are like a password plus a checksum. You also mentioned that they're one-time use. How do you enforce that? Is that a TTL or how do you?
Yeah, so it's combined TTL and like the first time that it actually is used. So when we generate it, we store it. And we store it along with a TTL. When a request comes in to do attestation using a join token, we do a lookup, and then we, number one, make sure that we're not exceeding the TTL. And number two, that it hasn't been used. And the presence in the database, the presence on persistence tells us that. And when we do use it, we nuke it. So that's how we enforce, yeah. And also, I should clarify that our join token is not quite as fancy as the Docker Swarm join token just yet. Right now, it's literally just a GUID. But in the future, we may change that to also kind of put like certificate hash and the stuff like Docker has done, because we see value there.
So I have a couple quick questions. It looks like sort of some missing pieces yet, but I think, people can fill this in their mind. So one of those is that you were explicitly associating which SPIFFE IDs go with which workloads, and you were sort of like that selector table was being explicitly done. Somebody could write a controller, a trusted controller, to do that automatically, right?
Absolutely, yeah. The when I did the registration on the CLI, that's actually just backed by an API under the covers, so anyone can hit that thing. And how you decide to do that, we haven't quite figured out the optimal way to do it with Kubernetes, but you can imagine that there are several approaches.
Yeah, so there's options there, and the same thing is that the join mechanism is pluggable also. So the token is one plan. I mean, another thing, and if you look at I'm thinking like configuration management systems and how they establish bidirectional trust. A lot of times there's like an approve API, like, hey, there's a bunch of requests, and then you can go in and manually approve those. So I could imagine that either one of those could be built with this flow.
Yeah, it's all fairly generic, and I think that if you were to have some system like config management, which is doing like orchestration of host provisioning, you could get pretty flexible and pretty fancy there. So I don't anticipate any problems on that front. But I do think like the ideal scenario is that we're using some sort of platform native attestation, and this thing is kind of automated, and you don't have to do those sorts of dances.
There's going to be a lot of situations where I don't think that's practical, and so having people to have choices where they can make trade-offs that make sense for them between automation and paranoia. Yeah, makes sense.
I've got a question about actually wiring myself up to use this. I can see you've got a workload sidecar. Are you guys planning to try to take advantage of the admission webhook feature that has been added for Kubernetes and that is going to allow mutations in 1.9?
So I'm not super familiar with those works. Okay. I would imagine that this would be like more towards the registration portion, right, or the consumption of the SVID.
I wasn't sure if you were going to try to do something really fancy, like if you want to automatically have the sidecar created for you.
Oh, I see.
And annotation, and we'll inject it.
Yeah, I think that's like a definite possibility. In the ideal world, the proxy itself knows how to speak to the workload API, and that's work that we will be doing shortly, but we just haven't got there yet. So this little sidecar bit, I hope to not have around for too long. But yeah, automatic injection is one thing. Another thing that we would probably want to utilize something like that for is, hey, where is this domain socket living, and how do I reach it? Some information that the workload over proxy can use to find that domain socket, or TCP if it's a TCP endpoint, then that could also be included at that point.
So David, I don't think it was said explicitly, but it's totally reasonable for Istio to use SPIFFE to get its IDs. And so these things are complementary. And so, Istio is doing all the fancy stuff with sidecar injection. And so instead of reinventing the wheel, that may make some sense. But one of the interesting things that SPIFFE allows for is there's a choice between using a sidecar or having the application itself be able to speak MTLS and talk to the SPIFFE API directly. So it's not it's not a either or type of thing. I think, on a workload by workload basis, you can figure out what makes sense.
I would look at it as like every piece of software right now that has configuration flags to pass in certificate, private key, CA cert, or TLS options. You could think about replacing all of those with a single option that points it at a Spiffy workload API and teach the software to configure itself via the API instead of from files.
So one other scenario that I don't think Evan covered here is that this stuff could be used both for workloads running under Kubernetes, but it could also be used for a generic way for bootstrapping the Kubernetes control plane itself. Now, there's obviously overlap with a bunch of the sort of cert rotation and cert bootstrapping stuff that happens with that's being built into Kubernetes, but this is essentially a more generic version of that stuff sitting outside of Kubernetes.
Oh, it was a neat demo. Thanks for showing us.
I wanted to just check one more thing. So like so you mentioned, so the demo was Unix domain socket, and then you mentioned briefly TCP as well. Is both of those things kind of on the table still, or have you kind of settled on one or the other, or?
That's a good question. So right now we're only supporting Unix domain socket. Personally, I think that supporting also a TCP binding on like a loopback adapter, for instance, probably makes a lot of sense for a lot of use cases. The reason that we haven't pursued that just yet is because backing your way into a process ID from a TCP socket is horribly non-performant under Linux. And so
yeah, that was kind of where I was going to go with that question. So like if you'd come up with a good way to do that, I was interested in what it was.
Yeah, no, we haven't quite come up with, sorry to say, and I've pushed on a lot of different places and haven't found anything better than the known method of walking proc. So I think probably what it's going to be is it is eventually, once we have demand or some good reasons to implement it, we will, but as a non-default, comes along with some sort of warning or something like that. Does that make sense?
Yeah, and I guess like the other kind of part of that is like if you eventually expect this to run on Windows, then domain socket is maybe not going to work there.
Yeah, absolutely. And like Windows portability is obviously we're not working on it right now, but this all built on Golang for a reason, and we do wish to be portable in those kinds of environments. And we've briefly looked at some options there. Windows has what they call name types, which may be an option as like a Unix domain analog, but we don't know quite enough about them yet to say whether for sure we'll be able to use that or not.
Same holds for any VM-based pods like Intel Clear containers.
Okay, well, thank you, everybody.
Thanks for showing it off, Evan. That's huge progress.
Yeah.
And great demo.
Thank you. Yeah, try not to take up too much of the rest of the time here. So, yeah, thanks for having me.
Thanks.
All right. So let's see if I can get the agenda here. All right. Hopefully, you guys are now seeing the agenda. Okay, silence. Gonna hope that's a yes.
Yes, we are.
And so the first one on the list, Google Cloud KMS removal. I heard Greg on the phone. Greg, do you want to explain briefly what happened, why it's going, and what the plan forward is?
Yeah. So the kind of history here is that in sort of 1.8 timeframe, we wrote this Google KMS plugin. KK started working on the Vault equivalent of the same thing. Essentially, the idea is for the 1.7 we enabled secrets encryption with the key on disk, and that's obviously not a good way to manage keys. So we want to have a better way to manage keys for Kubernetes. And so we started writing a Google KMS plugin provider that also had like it was like a plugin interface that would allow multiple KMSs, and that's what KK started writing to as well. And that was kind of fairly controversial when it went in because of it was going in the cloud provider kind of the old cloud provider model,
which was sort of actively being trying to deprecated. And so the kind of condition that went in under was this is going to be alpha, and then for beta, we will have to have some sort of out-of-process version of doing this. So instead of compiling it into the master and having this this KMS extension point kind of inside the master binary, the desire from the API side of Kubernetes was to get it out of the master and have some sort of defined API that we could write to. So we filed a bug for that and started. I had someone to work on that in Q4, and then they unexpectedly could not work on it anymore. So we're now in the position of we've got kind of Microsoft, Vault, and Google all trying to write these KMS providers. Kind of current plugin mechanism is not kind of the API team hasn't been sort of on board with. And so we've gotten into this position of what do we do now? It doesn't seem like, Microsoft wants to get their KMS provider in, Vault one, KK is trying to get the Vault one in. We're trying to move forward with the Google one. But there's no agreement on kind of the plugin mechanism, and so blocking kind of one of those out of that set doesn't seem like the right thing to do. So we've basically proposed that Google remove its KMS provider from where it's implemented now, and we focus attention on getting to this out of process KMS provider. And the kind of strawman idea there is we have some sort of gRPC interface to this KMS provider that could be kind of launched and iterated on independent of Kubernetes releases by the various people working on these things. So it doesn't exist yet, but the current kind of direction that I think we're going towards is to pull out the KMS provider, block the Vault provider on this work, and then focus on getting this work done, and then have them all use that interface. But it's not exactly a desirable situation to be in. But I'll also pass it over to KK to talk about his perspective on this too.
Thanks, Greg. This is KK. Can you hear me?
Yep.
Yes.
Yeah, I don't have much to say. I think it's the right direction for Kubernetes to take. It's been a learning experience for me, but we did put out a straw man picking up on what Greg pointed out in the bug. So I think for the next meeting, I'd like some input, especially from people like Joe, as to whether that's the right direction to go in or what changes we need to make. It's our initial thoughts. So it's an item that David had on the agenda further down. We can talk about it at next meeting, but we would like to see if we can get this thing done correctly out of tree so we can evolve these two separately. That's about it. I mean, I'll set aside my frustration. It really doesn't add any value here. That's about it. So I'm looking for input, for guidance from people more experienced than I or Beneath in this. That's really it.
Yeah, and so we also have someone starting on our team who I'm going to put on this problem as well too. So we'll contribute here, and we'll also we've kind of been discussing this with Daniel Smith, kind of on the Google side on the API team as well too. So they're happy to have some input there into this design. So yeah, we'd like to push this forward as well too. So there'll definitely be help from us.
All right. So it sounds like Google Cloud KMS is gone for 1.9, and we will look at a design hopefully next time for a replacement, but I'm guessing we don't expect that until at least 1.10.
Yeah, it'd be good to talk timelines here too, just briefly too. So I think we want to get this design done fairly soon and start work on implementation of that API kind of so it's ready for use in 1.10, I think. But yeah, it's obviously, I think it's going to be too late to get it into 1.9, so well past kind of where that can happen.
Yep. Okay, great. Want to make sure we're on the same page. So the next pull is one that's been open for a little while. It's a short circuit deny for authorization. looks like it's ready to merge. It's only noteworthy here because it impacts the self-subject rules review for webhook authorizers that Eric Chang was working on. And I wanted to bring it up and make sure that Eric and Mike were talking to each other. One affects the other, and you guys should at least be aware that you're interacting.
We are definitely aware.
Okay,
I think that short circuit deny is ready to merge. There were 2 typos and they are fixed now. Just waiting on, I got approval from, or LGTMs from Liggett after those changes and LGTM from Eric already, and then waiting for approvals. So if you guys want to go and finish that off, that would be great. And I'll get out of the way of Eric to do what he needs to do.
Okay.
Yeah, the one concern on my part for the self-subject rules review is that we are probably going to have to introduce some new API changes. I think it's hard for us to do this in a purely backwards incompatible way, just because clients will have to start understanding that a new deny mechanism. I wish we could do this in some sort of way that was transparent to the client, but it's hard for us to compute denies, because if you say something like, this person has access to everything, and then another authorizer comes in and says, accept this, we don't have a good way of expressing that in the API today.
Yeah, that's right. Yeah. And with short circuiting, it actually is an ordering problem as well. If you have an allow one, deny one, and then an allow one, and another deny one, the stacking can get hairy.
Yeah. That seems to summarize it pretty well. So the one I think our one saving grace, and David, we talked about this over Slack, is that we explicitly put this in the API documentation that this is not an API that should be used to compute ACLs. It shouldn't be used by external clients to determine access control. That's still the subject rules review, or not rules review.
Subject access review.
Yeah, subject access review is still our endorsed way. So this will give maybe some false positives for hints about what you can do, but it won't, if all clients are taking our recommendations, it won't cause somebody to accidentally gain access to something that they don't have.
Yeah, I agree. That makes sense. And I'm very glad we did it. The last one that I knew of on the list is aggregated RBAC roles. Unless the pull was perfect, and I kind of doubt that, it could use some review. I think the idea has reached agreement, and it's now into the exactly how it works, how it's implemented, and liking the test coverage, that sort of thing. But the upgrade, downgrade, reconciliation, it's all present there in that pull.
Do we get test coverage from the upgrade and downgrade tests once this goes in?
We should. We'll know whether, for instance, you nuked the entire admin role. Things we won't have on there, because I don't think we do, are related to if you mutated the admin role yourself to add a permission, did the upgrade preserve that for you? So I think I had one reconciliation test that demonstrated that would happen, but it's an area to look at. And also, hopefully people didn't do that too much, just as a general point, because then they'll get kind of frustrated now that they have a new way to do it better. All right, so for our designs, this time is just homework for next time. Take the time, read that external KMS doc. The strawman looks pretty straightforward. Normally I would laugh at a bytes in, bytes out API, but that's actually exactly what we need. So doc is up, and hopefully we'll be discussing that next time. I also have two discussions. First one is about admission plugins. PSP, we did some work on it just after 1.8 to deal with some ordering problems, and now with the changes to admission happening for the API server work related to external admission, we have a need to split PSP, or not split, but to have PSP have two stages, a mutating stage and a validating stage. The mutating stage, because of the way PSP works, also has to validate. But after it's finished, you need to make sure that no other changes in the admission chain have modified the security settings that were set for PSP and already validated, so you need to validate it a second time. I figured I'd go ahead and bring that idea up here, and gosh, I can't remember his name. There was someone on the Google side who was looking at this for 1.8, looking at PSP for 1.8.
I've been working on PSP stuff. Is Tim?
Does that make sense to you? The need for that split?
Yeah, definitely. There's a lot of issues that have come up with the mutation in the pod security policy. And a bunch of those were addressed recently by Jordan's changes to order the non-mutating ones before the mutating ones. But I think there's still a little bit of confusion around how the mutation should work, especially since you can have multiple pod security policies bound to service counts versus users. And it just feels like a space that needs a little more thought about the user experience side of it.
Okay, I could see that. I think what we are going to do, there's actually someone lined up from the API server side to go ahead and make this split. And when it's open, I'll go ahead and tag SIG Auth in it so you guys can take a look. It shouldn't be extensive surgery because of the way we've done it. An admission plugin can say it's both and gets 2 shots at a particular resource. But that's going to be something up and coming. The other thing that came up recently is the Kube API server insecure port. It's been around for a long time, but new features for the Kube API server have not. The Kube API server insecure port doesn't support new features. So you have things like API aggregation that require you to have a secure port because it has to be able to speak back and check things like authorization rules, right? And insecure port logically has no authorization. Unless someone can come up with a very strong user-facing reason for the insecure port needing to remain without being able to use newer features of the API server, I think we are going to deprecate it and eventually remove it. It will probably be a year-long process from now for full removal. But deprecating it now would mean we wouldn't be worried about trying to add new features. We already haven't been adding new features for it. I figured I'd bring that up here and see if anyone had a burning desire for it.
I think kube control defaults to that port.
Okay.
So there, I'm just trying to think, like, it's usually turned off, so or it should be turned off. So it may be that there's just some cleanup deprecation sort of changes to coordinate there too.
All right, I'll make a note of that here to find it there and remove it or change it. Probably over 2 releases, change it. So yeah, the morning. But yeah, our recommendation has long been not to use it, and yeah, just.
And I wouldn't be surprised if some like integration tests used it here and there. So that may be painful also.
We know there's going to be a little bit of pain involved in it. Stefan has been looking at it and thinks that most of the integration tests are going to be okay, just because of the way we can create a loopback connection.
Cool. All right, no worries then.
I just want to call out that like the GKE and the GCE default setup use it heavily as a localhost only port. Like add-on manager uses it. We know we want to move away from it, but it is going to be some work to get off of that.
And don't
You can
people
always
use like
emulate it
proxy
with
this
an
way?
authenticating proxy.
What's that? I'm sorry. Go ahead, Matt.
I was going to say, you could always emulate this with an authenticating proxy, right?
That's similar to kind of what we're thinking. We can basically spin up a kube config with a known user, which gets us some other benefits too for like local accesses that we actually want to disambiguate from just being something was on the machine and did something.
Yeah. I think that's going to be a good idea for you in general, just because we know of other issues in this area that are probably going to come up more and more. And it's not like we're removing it tomorrow, but I will send a note out to Kubernetes dev, and that idea for a local proxy, I'll probably mention in that note. That's a good idea. I hadn't thought of that as part of a transition plan for people to wean themselves off of it.
I seem to remember that you can use kube control proxy that way too. I'm not sure though.
I think we probably just want to have those clients authenticate as users.
I
but
recommend it, but yeah, I feel like I have to provide a path forward to someone and say I'm going to remove it.
So if anybody removes it, they will have to. I hate to say it, but whoever starts the deprecation and wants to actually remove from the API server to do that will need to make sure that tests pass on their PR, and that's where the brunt of the work is. So
that's right, because it's all in those hack scripts.
Yes, yeah. So whoever does the deprecation is going to have to fix this.
That's actually a good example of we should be very careful that everything that we fix, we then document as the deprecation. Like this is actually one where when we deprecate it, we'll get all of the things that'll probably break everybody else out there.
Yeah. All right. Well, I do plan to, it sounds like it's going to be okay to move forward with it then, so I'll plan to take this up and send the notes, tag the flag, and then start taking stock of where we are over the next release or two. All right. Unless someone has other questions. Of course you do, Clayton.
Of course I do. So this has been discussed at previous SIG Auth and container identity workgroup meetings, but one of the things that we were playing around in the container identity idea was part of that long-term arc of getting secrets out of the API server, specifically service account tokens being stored as secrets. That was on kind of our long-term roadmap for secrets that we talked about in 1.7 and 1.8. I think I've become convinced as part of playing around with this that we could move most of the service account token infrastructure out of the core of Kubernetes. And by out of core, I mean make it decoupled and potentially replaceable. I think I'm going to propose for 1.10 that we actively try to prototype to that point. Mike, Denise, and I have been playing around with it. I'm fairly convinced that it's possible. The right thing to do helps exercise a whole bunch of extensibility mechanisms that we don't have around security, such as disabling the service account token controller that's built in, using webhook authorization, going through the exercise of having a more canonical webhook authorization example, flex volumes for injecting secrets leading to CSI. And so I'm going to pull together a proposal or pull together like a high level, send it to SIG Auth, but I wanted people to kind of be aware that that's something I think about. From the OpenShift side, we're actually very incentivized to do this from a performance perspective, but it would also lead to things like making it easier for third parties to inject CA trust domains into the cluster. And so I think it's a good discussion point independent of container identity and SIG Auth for doing a better job of making authorization pluggable and better isolated.
You're saying authorization, but I assume you mean authentication in this case, since we're talking about a service.
Yeah, sorry, authentication.
And your sketch, is it going to include how I get these injected into my containers on a kubelet? Okay.
Yeah, that's the flex volume side as Mike and I work through.
That's fine. I just want to make sure that it comes in the sketch.
Yeah, I think this is kind of a way of looking at the interplay between an identity provider, an authenticator for the cluster, as well as external identity integrations, and how there's a bunch of overlapping extension points that would be very useful for many different types of integration. So try to pull that together and then link it to some of the existing discussions before we get too much further in 1.9.
I just want to say that Spire would be perfect for this.
Exactly. And even the work that we've been talking about in container identity for jot minting for people who want to continue a kube cluster, like done right, we kind of integration and Spire and a more like a simpler like continuation path and potentially third-party authentications that we haven't even thought of yet. And they all kind of benefit from the same sets of changes. It would not be this is not necessarily a scope increase. It is more of a pull together something that realistically shows what this is like. And actually that fixes a couple of problems in Cube and it might be optional for some people. I think like on the OpenShift side, I'm already kind of mentally convinced that this is what we would want to do in most of our clusters, just to deal with some of the security, like the getting service account tokens better secured. It's just a straight up win, and it's also a scalability win.
Well, sounds interesting to me.
Okay.
Yeah, on the Google side too, we're definitely interested in this stuff for kind of getting Google identities issued to Kubernetes as well too, which is the problem that Mike and CJ are working on at the moment. So yeah, we're very interested in this space as well.
Yep, and I think like on the Spire side, like there's kind of that spectrum of how much control. Like I think this is the Istio spectrum as well, which is there've been a lot of discussions about how to plug into Kubernetes at a number of different levels, and increasingly, there's kind of platform, middle platform, which is kind of like some hybrid, which feels very integrated, but has a bunch of separate stuff, and then there's the more loose integration and the run on top as a pure plugin or sidecar. And I think like part of this would be to say, you can do this in these three ways. Here's some examples that help you orient about what you want to do with Kubernetes going forward.
All right. Well, I look forward to seeing it, and I think we're ready to call it here. So, good meeting, guys.
Bye. Thanks, everyone.
Thanks.
Thanks, guys.